Welcome, everyone. I can't really see anyone bar like the presenters at the moment, but I'm hoping everyone else can hear us / me at the moment. I think everything's working. We've tested everything out. Cool. So Leah asked me to host us tonight. Don't know how this is going to go. We shall see. It's my first time doing this too. It'll be fun doing this. So I think we'll get straight into it. And I think our first speaker tonight is Patrick, and he's going to talk to us about deep learning with Azure Machine Learning Services. Whenever you're ready, Patrick, you can take over the screen.
All right, thanks, Akanksha. Can everyone hear me? I'm gonna share my screen. Can you all see my screen? Okay, cool. I'm getting a lot of yes from the chat window. Okay, I'm gonna start. Hello, everyone. My name is Patrick. Before I start my talk, I'd like to say thank you to Leah, Akanksha, and all DDD Melbourne crew to organize this event, especially turn this from an in-person session to an online session. It's great effort, but it's definitely necessary in this coronavirus outbreak period. Everyone should stay safe and stay healthy. This is actually the time I'm delivering a talk in a virtual environment. So I'm very excited, a little bit nervous, but I'm very keen to find out how you guys audience think about it, how you feel about it. Today, I'm gonna talk about deep learning with Azure Machine Learning Service. Deep learning is a blazing topic these days. It is about constructing a layer of networks that imitating human brain's activity, so that when it's been fed a structured data, it can self-train itself to produce a model, so that later on we can use the model to predict the outcome of the same new coming data. And over the years, data scientists and engineers have gathered a lot of experience building up the deep learning solution, and they have established and agreed on a well. It is actually a pattern, so that when we leverage this pattern, we can better deliver a machine learning solution, especially bring it from laboratory to production. Azure Machine Learning Service definitely helps improve your machine learning workflow and helps you to better build your machine learning solution. Again, my name is Patrick. I'm a senior software architect at SSW. These are my social media links. And today, I'm gonna briefly cover an introduction to machine learning workflow. And then I'll walk you guys through a machine learning service use case. So recently, my friend Anthony and I have been working on a side project. And with that side project, we've been collecting data. So what we are collecting is a tennis match result from some local clubs around Anthony's suburb. Now we have some data. It's not a lot, but we want to use the data to train a model, so that we can, when we get a result from our next match, when we get the teams in the next match result, and this can help me to get some pocket money and win bets. So from now onwards, I'm gonna stop the video, turn off my camera so that we can focus on my presentation. To get started, I'd like to expect you guys have some understanding of machine learning. You know TensorFlow, Keras, you've tried some Python programming before, and most importantly, you have an Azure subscription. Machine learning workflow is commonly agreed beginning from data feeding and ingestion. So what it means is that your machine learning data can be from any type of resources, such as IoT, Spark, your big data platform, etc. So the ingestion process would feed the data to a data store Azure Machine Learning or Machine Learning Service should provide. And from there onwards, we can conduct the subsequent operations. Next thing we do is feature engineering, and by which we can trim out the unnecessary / dirty data, and we will transform the features to a shape that can better fit into an algorithm to train the model. Next, we're gonna train the model, of course, and then we get the model. What we do with the model is we're gonna register it to a model repository, and we put a version label to it so that we know which version that we can serve later as a service, and usually it's a REST service for other applications to consume. By consuming it, what I mean really is to feed the new data to it and get the prediction out of it. And here's a picture I got from Medium, one of the posts on Medium, that illustrates this workflow in a vivid way. So as we can see, when we start a machine learning solution, we start from preparing the data, and then we're gonna build a model in our IDE, and then we can train the model. We run the training process on a dedicated compute target, and then we can register and manage the model. From there, we can build an image. This term would sound familiar to engineers, because we want to have the same model train and train again when we get new data, but we want to put the appropriate label on it so that we know which model image we serve later. Now, I'm gonna jump on to Azure Portal. So to begin with machine learning, all you need is a machine learning workspace. So this is how a machine learning workspace look like. You can easily find it on Azure Marketplace. I've created it beforehand. So as you guys can see, a little bit unlike other Azure services, it's organized in its own way. It has experiments, which is essentially where you run your training script, and your pipeline, you can apply DevOps process to it, and you need dedicated compute target to run your experiment, and you can version your models and etc. Instead of working here over Azure Portal, I like to recommend this Azure Machine Learning Studio to you guys. It gives us a much better UI way of playing with Azure Machine Learning Workspace. We can click to launch. I already got it open here. So as you guys can see, it's the layout similar to what we saw on Azure Portal, but it's more dedicated to Azure Machine Learning Service. So as I mentioned before, in a normal machine learning workflow, we're gonna start with data sets. You can inject or create data sets from any of the resources, whether it's a local file or other data store or storage account, etc., or from web services or from anything. So one thing to mention here is that whatever I show you guys here can also be done via code, means that you can automate your data ingestion process easily. I've already got a 10 data set. Loading this dashboard, we can see a detail of the data set, where is it, how large is it, etc. And we can also, more importantly, see an instruction offered by Azure to show us how to consume these data sets, so that we can automate this process in code. We can parameterize this, names, subscription, and we can consume it easily. So we quickly explore it. It's a very simple data set. It might seem very naive to an experienced data scientist, but this is one of our side projects. So we have the team number. We record whether there's a head start or not. In the snapshot, by win or lose column. We're going to use this data set to train our model. I've prepared a training script in Python. Hope you guys are still following it. So I'm now currently showing my Visual Studio Code editor. and show you guys a training script I prepared earlier. So as you guys can see in the training script, we firstly supply the subscription ID, the resource group, and workspace name, so that we can instantiate a Azure Machine Learning workspace in our training environment. And then we get the data from the data set, so that we can use the data sets later on to do feature engineering. So now I just get the features because the data has been cleaned beforehand, but you can do more data feature engineering based on your preference and your need. And next, I just simply create the model. I feed the model, I feed the data to the model, and then we run the evaluation, the training process, and we evaluate it. And next, we save the model locally. You can either save the entire model in any of the formats you prefer, whether it's TensorFlow checkpoint, or it's ONNX or H5, or you can just save the weights. I'm saving the weights in my demo. And next step is about model registration and versioning. We register the model, we give it a name, so that, and we can give it tags, of course, so that we know this is the model we trained just now. We can even furthermore deploy the model as REST services in code, but I'd like to deployment can be done via Azure ML Studio. So for now, I'm just going to run this script on my local machine, so that we can expect to see a new model being created on Azure ML Studio. As an alternative, to fully leverage Azure ML service, you can submit this training model to your dedicated compute target to run it as an experiment on Azure. Oh, we've done it. We've got a test accuracy. It's not very high. It's close to 0.5, so almost pointless. But this shows you the concept. And for you, any of the audience who has years of experience in data scientists, so you're welcome to help me to improve it. So just show you guys the alternative is you can submit this training script as experiment in Azure. Once you've installed the Azure ML extension from the extension marketplace. So to submit it, it's very simple. You right click on your script, and you need to supply a training configuration, and I've already created a compute target beforehand, and then you need to submit a run configuration to tell the compute targets your dependencies, and be submitted. Now we're gonna flip back to ML Studio, and we can have a look at a model. So as you guys can see, I've just trained one model just now, 1 minute ago. If we have a look at a model, what we can see is the description, the text we put on it, and we can have a look at it. Only registered the model weight to it. You can also register the entire model folder if you need. And from here, we can click the deploy button to deploy this model as a REST service. So we give it a name, DDD test service, just 10, just give a number, just put a description. You can either deploy it as a community service or a container instance. I'm gonna select container instance here. Now, you need to supply a entry script file, which is the scoring script, and also the Anaconda dependency file. I'll get onto it very shortly, but let's click the deploy button first. Okay, while we're deploying, I can show you guys what the scoring script looks like. It is actually very simple. It provides two methods. One is the initialization process, the other is the run process. In the initialization process, you can load your model if you need. And for those of you who use TensorFlow, you can have a TensorFlow session the init method, and then you keep the session open and keep getting data from the run method and feed the data to the session that you kept opening in the init method. But for now, I'm just I'm just constructing my model in the wrong method, and then I load the weights from the model paths I got from the Azure ML model registry, and I get the data, and I feed the data to my model so that I can predict classes. So it's a binary classification so that I can know whether the team number and head start data I feed in would lead to a win or lose. I also supplied an Anaconda file, which simply specified the dependencies of your running script. Your scoring script. So now we're still deploying it, but I have another services that I deployed, created and deployed earlier. We're gonna call this service to show you guys how it works. So to call it, we just supply the Azure Container Instance URL, and then we call the /score method with the post request. And as what we saw earlier on the data set, we supply the team number, team 1 number, team 2 number, whether it is a head start or not. For my model, I keep the original result. But this is optional when you use TensorFlow or other training frameworks. So we're gonna click send. Oops. Yeah, as you guys can see in the response, we get the scoring result, the prediction back, which is 0 means lose. So if team 18 versus team 37 with 0 head starts, team 1 would lose. So now I have my my mini machine learning solution up and running in a simpler way. And as a recap, these are the steps that I followed. First of all, we ingest the data to Azure ML data sets, and we start programming the training script, and then we submit the training script as experiment, or we can run it locally or on any virtual machine. And of course, we run it, and then we can register the model and put a version on it. And later on, we can deploy it as a REST model, as a REST service, so that any client application can consume it and get a prediction. So now I can kind of trust my machine learning solution to predict the next tennis match in one of the local tennis clubs, and I can win some bets and pocket money. As a summary, today I've covered a very brief introduction to Azure to a machine learning workflow, as well as Azure Machine Learning Service, and I'll show you guys a short demo to one of my side machine learning projects. And I hope you guys all enjoyed. I want to say thank you. I think I'm gonna skip the Q&A session. But you guys are most welcome to reach me via any of the social media links. And also, I'm planning to submit the full version of this talk to give more details and things to NDC Melbourne this year. So any of the feedback is welcome. Let me have a quick look at the chat. Oh, thank you, guys. Thank you. And special thanks to Leah and DDD Melbourne crew. So shall I hand back to MC now?
Yeah, cool. Thank you so much. Yeah, to be like, I was about to start clapping, and then it was like, well, you can't hear that, and I'm very confused. So I'm liking all the claps in the comments. So if people want to do that, that's a great way of doing this. Exactly, ritual clapping. I like it.